physics kids, Mr. Johansson here. We're going to be going over mechanics number 10. And in this we're starting to get into adding vectors that are not necessarily all along the same number line. Right now we're going to be adding perpendicular vectors. That's a lot easier, but we got to start someplace. So take a look at the quote, will you? You may fire when you are ready, Gridley. A great American history quote. How does physics tie into that? Figure that out, write it up, submit it, I'll give you bonus points, okay? Physics figured very deeply into everything that happened after that quote, and it changed America's standing in the world. Of course, it involves war and how it was conducted, but it certainly changed how America and the world related to each other. So write up a little essay and I'll give you bonus points on that, right? See how physics ties into the world. All right, so vectors. We're going to be doing vector addition, all right? Both graphically and mathematical vector addition. So on this, we're going to start adding graphically 7 newtons and 8 newtons. But they're vectors, so there has to be another component. If you look at the mechanics paper, it's 7 newtons at 90 degrees and 8 newtons at 180 degrees. Okay, so these are the vector components we're adding. This is 7 newtons at 90 degrees, and this is 8 newtons at 180 degrees. Now, if we're going to add them graphically, we have to measure out the length and scale it very carefully so that 7 is 7, 8 is a little more, 8. And we have to be very specific on the scale because we're going to be using that same scale to discern what the answer is. So let's start out adding them graphically, and we'll go from there. Now, graphical is inherently inaccurate. I'm using a thick piece of chalk. I'm going to be using a large protractor and ruler. These do not make it easier. These make it a little bit more challenging to get the exact right answer. So how correct your answer is depends on how carefully you conduct yourself. First thing we're going to need to do is make an XY axis so we can add these things. Right? Now when I make my XY axis, I'm going to do my best to draw a nice horizontal line, as horizontal as I can get it. Now that's going to be the reference line. So that's the x-axis, so the y-axis, I'm going to have to make sure is at 90 degrees to that. And the protractor will help me do that. So I now have a pretty well constructed XY axis. And I can place everything on that. So 7 newtons and 8 newtons. Well, to do 7 newtons, I might want to do 2 centimeters per newton. Just to make an easy scale. You at your desk would probably use 1 centimeter. A nice ruler, just use 1 centimeter. So that's my 7 newtons. And 8 newtons would be 16 centimeters in that same scale. So I'm going to make this as parallel to that as I possibly can. And I'm going to be going down 16 newtons. And I am adding this, notice, tip to tail. Any vector addition you do, you must add them tip to tail. Not tail to tail, not tip to tip, tip to tail. Doesn't matter what order, but you got to add one vector onto the next. So here was my 7 newton. Let me color it up for you. Here is my 7 newton. Here is my 8 newton on the tip of the 7 newton. Now I can start and go 8 newtons down and 7 newtons over. That wouldn't change the answer, but I do have to add them tip to tail. Kind of important. Well, when I'm all done with that, I want to measure what the length of the resulting vector is. Actually, I should color this in red because it's the resultant. The resultant is the vector you end up with. you go from your first origin to the end of your last vector. And what is the angle or what is the measure I get here? I get 22 centimeters, which means 11 newtons, because I had 2 centimeters per newton, so I would say 11 newtons. Now, I know I'm going to have a little bit of error here, but that's the best I could do with this method. 11 newtons, and what's the angle? Well, the angle's kind of tricky, just a little bit, because remember, straight up is 0 degrees, straight over is 90 degrees, straight down is 180 degrees, and on the other side is 270 degrees. So I'm going to use my protractor, and I'm going to measure directly, but I am measuring from my 0 line. So rotating through my 90 line, and I am ending up at 136 degrees. So my answer would be 11 newtons at 136 degrees. Pretty straightforward. So you're adding the vectors tip to tail. You have an XY axis. You're trying to make sure everything is perpendicular. You're being as careful as you could be. With a protractor and ruler and graph paper, you could get excellent results on this. But will it be as good as the mathematical version of this? I think not. So let's try the mathematical version of this. We don't have to sketch things all that carefully because we're not taking our data from that. 7 newtons, 8 newtons. I'm making the 8 newtons a tiny bit larger than the 7 newtons. Right? And connecting them, I want to know this. So how do I find this? Well, a squared plus b squared equals c squared. Do you remember that? Pythagorean theorem. So 7 squared, 49, 8 squared, 64. Take the square root of that, you have 10.6 newtons. 10.6 newtons. That's better. That's pretty close to the 11 newtons I got. Better answer. Okay, how do I find this angle, theta? Well, if I remember that I was on a XY axis, I have to have 90 degrees rotation down here, then this as well. Well, what's the data I should use to get that particular angle? Do I want to use derived data or do I want to use fresh, clean data that couldn't possibly be wrong? I think you'd agree fresh, clean data is going to be the way to go. That is going to be this and this. They were givens in the problem. Any problem you have, you want to get as close to givens as possible, the least derived data that you possibly can do. So certainly that would be it. And in terms of our functions, the tangent function is going to be good. Tangent is opposite, from this angle, opposite. So tangent of theta, opposite. 8 newtons over adjacent, divided by 7 newtons, is the tangent of theta. So we have 8 divided by 7. That equals, and then when I press inverse tangent, I get about 49 degrees. First, check yourself. Does that look right? Well, 8 is a little more than 7, so I would expect this angle to open wider than 45 degrees. So I'm comfortable with that. Not a lot wider, but a little wider than 45 degrees. But remember, I have to add on that 90 degrees. So 49 degrees plus 90 degrees, that is going to be 139 degrees. So the answer to this would be 10.6 newtons at 139 degrees. That is how you do that. Now, this is components that are lying along the x and y axis. Pretty straightforward to do. Once the components are not on the xy axis, that becomes ever so slightly more challenging. Okay? So, next we're going to start solving for non-perpendicular vector addition. How do we do that? All right, this is not nearly as difficult as people might think. So I'll give you some basic steps and guide you through it, okay? If I were to add, let's come up with something. 5 newtons at 30 degrees and 8 newtons at 110 degrees. Oh, let's give it 120 degrees. Okay, before you're going to do it, let's think about it. If I draw an XY axis, and I sketch in 5 newtons at 30 degrees, that's going to be something like that. Okay? And I could label it 5 newtons. There's 30 degrees right there. Well, if you remember your trigonometry, that 5 newtons is really made of 2 other vectors. It is made of a component in the x direction and another component in the y direction, such that if I add this vector to this vector, I get that vector. Well, that means I could take that 5 newtons and I could break that 5 newtons into its x and y components. Okay? Let's think about that. If I break that into my xy components, and I have another vector and I break that into my xy components, can't I add then all the x's? Can't I add then all the y's and come up with a new xy value for as many vectors as I want? And then if I have a new xy value, can't I take that and construct a new right triangle out of that xy component? And then can't I do all the measurements and find out the total from that? Well, that is exactly what we're going to do. So we have 5 newtons at 30 degrees. We have over here 8 newtons at 120. That's 180 degrees. This is 90 degrees. So how do I find 120? Well, that would be a 30-degree rotation down from 90. Looks like I'm about ready to go. When we're about to do this, we're going to construct this table. This table will hold all our data. It's going to be really fairly straightforward to use. Let me turn it over this way a little bit so you can see the table. All right, so the table is going to have x, y, and we have to label our vectors. So let's label the vectors 1 and 2. And this works for as many vectors as you'd like. So, for vector 1, what do we have? So when you make this table, make it big. You need 2 lines in each space. So you're going to have something written here, you're going to have something written here. So make sure you do that. Down here, vector 2, and the total. So, for vector 1, when we're about to do this, we drop to the x-axis. You must drop your line and complete your triangle to the x-axis. Otherwise, this method will not work. So, what do we have on the included angle here? Well, that's 60 degrees, the complement of 30 degrees. We already have 30 degrees in on the other one. So, on the table then, for my x value, that's down here. For my x value, well, I have, how would I find that x value? All right, I have 60 degrees, 5 newtons refers to the hypotenuse, and if I use the ideas of SO, COT, TOA, sine, cosine, and tangent, this isn't so hard. I see that I have the hypotenuse, and I'm looking for the adjacent side. So hypotenuse and adjacent, that's cosine. So thus, cosine 60 degrees times 5 newtons. Is it positive or negative? Well, remember, going up this way is positive, going to the right is positive, down is negative, and left is negative. Okay? So this is positive. How do I find my y value of this? Well, that's the opposite from the 60 degrees. I have hypotenuse and opposite. That's sine. Sine 60 degrees times 5 newtons. Notice the symmetry there, just cosine in x. Y is sine, and you can think of it as y sin. It's a philosophical question, you could work on that. But y sin. The sine function will always be on y, all right? And we see that that is also positive. And working then below it, we do the same thing. Cosine, in this case of 30 degrees, times 8 newtons. Sine 30 degrees times 8 newtons. Consider positive or negative. Well, this y value here, that's a negative value, isn't it? All right, so the x, yes, is positive. The y is negative. Now I'm ready to solve these things in the table. Let's take a look at this table. We're going to make all our solutions right here. Right? This goes pretty quick. All right, so 60 cosine times 5 equals 2.5 newtons. Positive. 30 cosine times 8 equals 6.9 newtons. All right, and that's x. So they're both positive there, so positive. So 6.9 newtons plus 2.5 newtons equals 9.4 newtons. Lovely. Go over here. 60 sine times 5 newtons is 4.3 newtons. 30 sine times 8 equals 4 newtons. But that's a negative 4 newtons because it's going down. All right, so I have 4.3 newtons and 4 newtons. That's 0.3 newtons there. And that's going to be positive. This is positive. What do I do now? Well, I take those numbers and I just plot them up on a new xy axis. So I sketch in an xy axis and I plot those. My x value is 9.4 newtons, and I came up 0.3 newtons. So what is this here? Well, Pythagorean theorem will give us the length of the vector. So that's 9.4 x squared plus 0.3 x squared equals, take that square root, and we're still within, the later figures have changed a little bit, but it's still so close to 9.4, it still reads as 9.4 newtons. What is this angle here? Let's just worry about the angle here, then we'll talk about how to relate it to the bigger triangle. Well, these two pieces of data are the best pieces of data I have for that, so it's going to be tangent of theta equals, TOA, opposite, 0.3 newtons over 9.4 newtons. So 0.3 divided by 9.4 equals, and I'm taking the inverse tangent, and that's 1.8 degrees, just about what you'd expect, right? So if this is 1.8 degrees, what is the measure of this line? Well, it would be 90 minus 1.8. So 88.2 degrees. So this is 88.2 degrees. Therefore, my final answer would be 9.4 at 88.2 degrees. That's how you do that. You break each component into its xy values. You add the xy values. You construct a new xy axis and plot your new vector on that, just adding those x and y components. So it's a lot of very simple steps. What do you have to make sure of? Make very sure of positives and negatives. That's an easy place to mess up. So a couple more examples for you to try, and we'll check your work later. Thanks so much for watching.